Hey everybody, welcome back. We're going to take a look at the quotient rule. Let's say this is 33C quotient rule. Let's say you have J of X equals F of X over G of X, and you want the derivative. The way I remember this, and I'm going to tell you the jingle before I write it. I'll write the jingle as I'm doing it. Low D high minus high D low over low squared. Low D high minus high D low over low squared. This means we're going to have the thing on bottom times the derivative of the thing on top, the low times the derivative of the high, minus the high times the derivative of the low over the low squared. So if I wanted to put it in a big box, I'll write it down here. ddx of f of x g of x over g of x is an easier way to do it is put them in the order we had before with the f, just like the product rule, we had the f first. This is f prime of x g of x minus f of x g prime of x all over g of x squared. This is called the quotient rule. Now, I learned it like this. This is actually how I learned it. But I think this might be the easier form the way I did here. Notice this top part, the top, f prime of x, g of x, minus f of x, g prime of x, looks like the product rule with a minus sign. In fact, I'll show you where that comes from real quick. Let's just show you. This is f of x. Oh, can't show you. We don't have the chain rule yet. With the chain rule, I can show you. That's, I think, in a later section. Which section is that? No, that's in 3.6. I'm not going to be able to show you that for a little while. So that's what you got to remember. If you like the jingle better, low D high minus high D low over low squared, that works too. And that's when you're just doing the derivative of high over low. We're not going to do the proof. I'm going to save you the proof is actually easier to show with the chain rule building off the product rule. You can do the similar thing that we did with this long thing with the product rule up here. The derivation, there's something similar to it for the quotient rule. But instead of using it, we're just going to go with it. Let's look at some examples. Let's do ddx, example 1. Let's find the derivative of 3x plus 1 over 4x minus 3. So high here is 3x plus 1, which means the derivative of high is just 3. ddx of high. And low here is 4x minus 3, so the derivative of low is just 4. So I'm going to do low d high minus high d low over low squared. ddx of 3x plus 1 over 4x minus 3 equals low, which is 4x minus 3, times the derivative of high, which is 3. And I'm going to say minus high, which was 3x plus 1, times the derivative of low, which is 4, all over low squared. Now you should multiply this out and see if it cleans up. I get 12x minus 9 minus 12x plus 4 all over 4x minus 3 squared. It actually does clean up some. Look at that. The 12x's cancel. Oh, I said plus 4. That should be a minus 4. Remember, you got a negative times everything in there. So we end up with negative 13 over 4x minus 3 squared. That's nice. Let's look at another one real quick. We're going to do the derivative of 1 over x cubed. So high here is 1, so the derivative of high is 0. Low here is x cubed, so the derivative of low is 3x squared. Remember, we're doing low d high minus high d low over low squared. Low is x cubed times the derivative of the top is 0 minus the top times the derivative of the bottom all over the bottom squared. This is 0 minus 3x squared over x to the 6th. This is negative 3x squared over x to the 6th, which is negative 3 over x to the 4th. Now, there was another way to do this. This is the same as doing ddx of x to the negative 3. You bring the power down, lower the power by 1. And remembering that negative exponents means moving it to the bottom, we get that. So that is the easier way of doing that problem. But I just wanted to show you that the quotient rule works. In fact, the textbook does negative exponents after doing the quotient, but I didn't see any reason to do so. Okay. Pause this video, and we got one more with challenge problems.